All right, welcome. Today we're going to put on our detective hats and dive into the world of scientific research. Now, I know that can sound a little complicated, but you'll see that figuring out a scientific puzzle is actually a whole lot like solving a classic whodunit. So let's get into it.
So let's start with the big question, the one that kicks this whole thing off. When scientists are staring down a real mystery, a brand new disease or some bizarre phenomenon, how on earth do they even start to get to an answer? What's step one?
Well, it turns out it's a lot like a detective story. Seriously, it's a process. You gather clues, you look for patterns, and then, finally, you test your main suspect to see if your hunch was right all along.
Okay, let's start with phase one, gathering the first clues. Picture a detective arriving at a crime scene. What's the first thing they do? They don't start pointing fingers. Nope, they just look. They observe. They take notes on every single detail they see without changing a thing.
And in the world of science, this first step has a name. It's called descriptive research. The goal here is super simple, just describe the scene. Researchers are basically fact finders, just reporting what's going on without trying to control anything. They're describing things exactly as they are.
Now, the most fundamental version of this is something called a case report. This is when a scientist or a doctor spots something totally new, something they've never seen before, a single, really unusual case. It's that first piece of evidence that makes our detective stop and go, now that's weird.
But hey, one weird clue? That could just be a fluke, right? That's where a case series comes in. This is when researchers start collecting a bunch of similar cases. Suddenly, that one odd thing, it's not so random anymore. It's happening again and again. Our detective is starting to see a real pattern.
And if you want to know how powerful this simple step can be, just look at this. This single observation, just a collection of a few unusual pneumonia cases in 1981, was the first alarm bell. It kicked off the entire global investigation into what we now know as AIDS. It all started with just gathering a few clues.
All right, so we've got our initial clues. Now what? Well, we move on to phase two. It's time to step back from the crime scene tape and really analyze what we found. The detective isn't just looking anymore. Now they're actively trying to connect the dots.
This brings us into the world of observational studies. And the name really says it all. The number one rule here is you observe, but you do not interfere. Investigators are measuring things, like, say, exposure to a chemical and a health outcome, but they don't step in. They let nature take its course and just watch to see if there's a link.
And what's really fascinating here is that the big difference between these types of studies is all about their relationship with time. First, you can look at the present, taking a single snapshot of right now with what's called a cross-sectional study. Or, second, you can look into the past. In a case control study, you find people who already have a disease and you look backward in their history to hunt for a cause. And finally, you can look to the future. With a cohort study, you find a group of people and you follow them forward to see what happens to them over time.
So really, it all comes down to picking the right tool for the job. If you're investigating a super rare disease, a case control study is perfect because you start with the few people you know have it. But if you want to see all the different things that might happen from one single exposure, then a cohort study is way more powerful, even though it's going to take a lot more time and probably a lot more money.
And that brings us to phase three, the climax of our investigation. We've gathered the clues, we've found a pattern, we have our prime suspect. Now it is time for the final showdown, the test to prove, beyond a reasonable doubt, that our suspect is the real cause.
And that's exactly what experimental studies are. They're seen as the ultimate step because they don't just show that two things are connected, they're designed to prove that one thing causes another. This is where we finally stop just observing and we start intervening.
Now, the gold standard here, the one everyone talks about, is the randomized controlled trial, or an RCT. The idea is you take a group of people and then, and this is the secret sauce, you randomly assign them to one of two groups, a treatment group or a control group. That randomness is so important because it gets rid of bias and it makes sure the only real difference between the groups is the one thing you're testing.
So how does this big final test actually play out? Well, it's a controlled experiment. You start with your group of people and you randomly split them in two. One group gets the thing you're testing. That's our prime suspect, maybe a new drug. The other group, the control, gets a placebo or no treatment. And then you just compare what happens. If the only group that gets better is the one that got the drug, well, you've pretty much caught your culprit. You've got strong evidence of cause and effect.
Okay, so we've followed our detective all the way from the first clue to the final verdict. Now, let's just zoom out for a second and look at the entire toolkit. These next few ideas are kind of like different lenses that we can use to understand any study we might run into.
So think of it like this. You can put on different pairs of glasses to look at the very same study, and depending on which pair you're wearing, you'll notice different things and be able to classify it in different ways.
A really big one is the split between qualitative and quantitative research. Quantitative, you can hear the word quantity in there. It's all about numbers. It's about measuring things and testing theories with hard data. Qualitative, on the other hand, is about understanding the why. It's about words, interviews, observations. It's trying to explore ideas and come up with new theories in the first place. One isn't better than the other, they just do different jobs.
Here's another key lens: basic versus applied research. Basic, or pure, research is really just driven by curiosity. The goal is just to learn something new, to add to our big book of knowledge for the sake of it. Applied research, though, takes what we already know and uses it to solve a specific practical problem that's happening right now.
And this brings our whole detective story full circle. This is what's known as the hierarchy of evidence. You see how it all fits together? You start with those simple, descriptive studies to spot something new and come up with a hunch. Then you use observational studies to see if there's a real pattern there. And finally, you use those powerful experimental studies to prove cause and effect. Each step builds on the one before it.
So in the end, every single piece of knowledge we have, every medical cure, every scientific breakthrough, it's all the result of one of these investigations. Every single one started with the detective simply asking a question, which, I guess, leaves one final question for you. What's the mystery you're waiting to solve?